Well, good morning and good evening and good day to everybody from all parts of the world that you're joining in. Welcome back to the CIB Presidential Seminar Series that we broadcast from Purdue University. And as you all know, the theme for this semester and the last semester has been Distinguished Women Researchers in the Built Environment. And it is indeed, again, my pleasure to introduce our speaker today, another distinguished researcher in the built environment, Dr. Anita Terjek. Dr. Terjek is Senior Research Fellow, holds a master's degree in civil engineering, and got her PhD in field of knowledge of engineering and technology in 2017. She has been working for EMI Nonprofit LLC since 2006. She has more than 12 years of experience as a test engineer and more than 10 years of experience in educational activities. She was an associate professor at Budapest University of Technology and Economics, Faculty of Civil Engineering. She has proficiency in activities of research, innovation, standardization, approval, expertise in testing, laboratory, and on-site regarding several construction materials and structures. As an inspector, she was involved in initial inspections and continuous surveillance of manufacturing plants and factory production control systems throughout Europe. She participates in national and international R&D projects focusing on sustainability, innovative and environmentally friendly elements, the use of secondary raw materials, and the energy efficiency of buildings. She's a member of Materials Science and Technology Scientific Committee of the Technical Sciences Department of the Hungarian Academy of Sciences. She has membership in the Hungarian Institution for Standardization, serving as the chair of 2 technical committees. Her major research areas are material science, LCA-based product development, environmentally conscious, circular and modular construction solutions, as well as the analysis of the environmental effects of construction projects. Also, she is an active member of the CIB board. Please welcome Professor Terjek. Anita, over to you.
Thank you very much. Let's check if I can share my screen. Welcome, everyone. Yes, I'm gonna do it quickly. And yeah, I need to share it. Please confirm if you can see my screen.
Not yet.
Not yet.
Maybe you can share the entire screen instead of just your PowerPoint presentation.
Let's check it again. Yeah, now it's gonna work. Now it's gonna work.
Yep.
Yeah. Okay.
Here we go.
Yeah. Okay.
In the slideshow.
You're not in the slideshow mode. There we go. Perfect.
Okay, it's good.
Yeah.
Perfect. Yeah. So reply to me if anything is wrong, not the right size. So you can disturb me at any time. Thank you again for the introduction and welcome everyone. As you could hear, my name is Anita Terjek. I'm from Hungary, and actually, I think I don't need to tell much about my scientific background because Professor has told everything about me. I just would like to ask you if you have any questions during my presentation, write in the chat because I prepared a lot of slides. So I hope I can fit in this time interval what I got for today. And I will start actually with a short description of Hungary. I think you might not know about Hungary or not heard about Hungary. And that's why I would like to locate it in Europe. So as you can see on the screen, Hungary is a landlocked country in Central Europe, let me use my pointer so I can show it to you. So this is Hungary in the middle of Europe, Central Europe. It is bordered by Slovakia on the north. We have a small border with Ukraine, and then clockwise you can go through Romania, Serbia, Croatia. This one is Slovenia, and back to Austria to close the loop around Hungary. And we have a really big history, let's say like this, because our kingdom and the king, Saint Stephen I, that kingdom was established in 1000, as you can see. So during these lots of years, the form of Hungary, not just the governmental form or the geographic form of Hungary changed a lot. But as of today, we have this country with a lot of beautiful sightseeing places. We have two main rivers, the Danube and the Tisa, and according to these rivers, we can divide our country like beyond the Danube, between the Danube and the Tisa, and beyond the river Tisa. We have the Lake Balaton, which is a really good place for tourists, and this is the largest lake in Central Europe. And I would like to mention that not just the landscape is beautiful, we have a really good science background, and just to mention you that the lady showing on this picture, Katalin Karikó, who lives in the US. She is Hungarian. She was born in Hungary, and she is the one getting a Nobel Prize last year. But beside this, we have many famous researchers and inventors going back in the history. I think the most famous in the US or around the world is the inventor of the magic cube, and Rubik, and you use from now on then the ballpoint pen, which was invented by a Hungarian man, László Bíró. And just to show the relation between the two countries, Hungary and the United States share a lot of common moments in that case when Hungarians were to flee from Hungary to the US. There was many waves of emigration. The last one was in 1956 when the Hungarian Revolution failed, and that led to this emigration of a lot of fleeing people from the persecution after the revolution. And I just put a small statistics here showing the largest Hungarian American populations according to the states. And let's check my company. And I would like to show that company and talk about that company in details. EMI or EMI, we usually in Hungary, we just say EMI as a short term or the abbreviation of a really big name. In this abbreviation, E stands for building or construction, M stands for quality control, and I is innovation. We have a total of more than 300 employees, engineers and other research fellows and assistants. We have a laboratory building here, so we are doing tests, and you can see the headquarters, which is a new building here on the left of this picture. Due to our 60 years of experience in various fields of construction and with our trained, competent professionals, we provide high-quality services. As you can see on the screen, issuing different assessment documents, on-site and laboratory testing, inspections, technical expertise, research and innovation are part of our daily work. As an independent professional institute, we perform the technical assessment and certification activities required for the distribution and installation of construction products. We are a notified body. We have a notified body number in accordance with the requirement of the construction product regulation. And I would like to show some pictures about the jobs, the activities, what our colleagues are doing in this directorate for engineering services. And some really famous buildings renovated or rebuilt according to the original plans. In the castle part on the Buddha here, just to get a glimpse of Budapest and Hungary, and especially the activities of EMI. And not just in the laboratory, we do tests, but we have these trucks, these mobile lab group, and we can go on site and doing those tests on site. Where I belong to this directorate, the Research and Development Directorate, we have many national and international projects, 15 ongoing international projects, what we are dealing now. Let's see the international activities of EMI. As Professor Hestek mentioned, we are in many international associations. We give member to those associations, the CIB, the EMBRI, the IOTA, or the ECTP, the European Construction Technology Platform. I will show our activities, providing the details of these international projects, what we are doing, and just have another slide showing what we are doing. Beside these two directorate activities, we are involved in regulation and other projects like sectorial researches, technical security control elevators. And now, back to my title, what I would like to show you, the sustainability. And regarding sustainable construction, we have to take into account the building stock. That is what I would like to show you, our Hungarian building stock, the typical dwelling types, and showing those problems, what we are facing today. Our built heritage is important, which we cannot really eliminate for technical, cultural, or economic reason. In terms of the built environment, the existing building stock accounts for by far the most carbon emissions, and where the greatest opportunities for savings can be found. And I just collected the principles of sustainable construction. We can say we have to minimize resource consumption, so conserve. We have to maximize resource reuse, use renewable or recyclable resources, protect the natural environment, create a healthy, non-toxic environment, and as well as pursue quality in creating the built environment. I think you are familiar with these terms: sustainable development, sustainable construction, sustainable development strategy, and know the three pillars of sustainability, which are economy, society, environment. And I just learned that this diagram is called the wedding cake, how we can represent the three pillars of sustainability. So the construction industry, as I mentioned, is facing new challenges. I think the same happens in the US, but we are facing here in Europe and in Hungary. Sustainability, in this case, depends on achieving the lowest possible environmental impact while encouraging social and economic development. The society demands new infrastructure as we are moving towards into cities and our cities getting bigger and bigger. So we have to take into account reduction in the consumption of energy and resources and implementation of sustainable or green construction. These words are, think, not new to you. These are the Sustainable Development Goals. And we can say that these goals are ambitious and indicate a challenging path ahead of us. These SDGs were designed to be a practical implementation guide for sustainability, consisting specific targets and measurable indicators. And in order to understand it better, we need to know the building and its environment, how they act upon each other. The environmental impact of buildings is also significant in terms of energy consumption, greenhouse gas emissions, and waste production. This is especially true if we look at the entire life of the building. As you can see on the picture, from the extraction of raw material to the production of building materials, through the construction, and then the end of the life cycle. And when I teach in the university, especially this construction subject, I usually talk about the two extremes, the two sides of the scale. We can talk about the dark green and the light green group. The dark green group says back to nature, use only natural materials, use traditional technology, and minimize energy consumption. You can follow it or check it out in smaller settlements, family houses in Hungary. And on the other side of the scale, we can talk about the light green group, which say that we can use high-tech application. These are expensive but progressive solutions and lead into a large investment and in urban environments. And when we are starting talking about sustainability and the possibility how to improve sustainability, we have to take into account the life stages of the building, especially the design phase, which has significance. As you can see on this small picture, even it is in Hungarian, you could understand what I would like to explain. So when we check that landscape and we would like to place our dwelling somewhere, we need to know the landscape, we need to know the wind direction, we need to know where the true north is, and we can place that house in the perfect place if we know these tricks how to do that. So we can follow these aspects, what I collected here. So fitting into the landscape is important, and to keep the surrounding of that dwelling, of that building, to keep flora and fauna, use those materials that are environmentally friendly. And when we talk about the structure, we need to minimize resources during construction and demolition, and especially taking into account the building, the technical building system, so the mechanical engineering part, to use renewable resources and low emission energy carriers. The first project, what I would like to show you how we could reach not the students or not just the scientific group around us, but we have this duty to talk about sustainability to the ordinary people, to the men on the streets. So this project was about to raise the awareness and widen the knowledge of the generic public about the environmental impact what we are facing in the building industry. We prepared a handbook, not just in the national languages like Hungarian, you can see the consortium, or Italian or Finnish, but we provided the English version of it. And in this handbook, we talk about LCA, we talk about requirements, and we collected best practices. And beside the handbook, we provided a web application where the people can check the environmental impact of different building materials, different structures. And this is the point where I would like to show you one type of our building stock, which is this small house, part of the vernacular architecture, the origin of Hungarian folk architecture that goes back several centuries, made of earth, because earth was a cheap building material when getting wood became difficult and expensive in the 18th century. So it has become a frequently used technique adapted to the local materials characteristics. This earthen architecture, as we can say, is one of the most original and powerful expression of our ability to create a built environment with the available resources. If we check out the ground plan, the floor plan of this small house, you can see that there's a porch, a veranda, as here in this picture, providing us with shading, natural shading in summer. So in the handbook, we put together all the requirements related to building structures and buildings, but in a simplified way. So not a scientific version, but a simplified way how our family members or somebody whom I can meet on the street can really understand the problem. We provided that a small simplified house showing the different elements, the different building elements, and in order to understand the problem, we provided the typical structures for these building elements and how we can evaluate advantages and disadvantages of the different types. In this handbook, there is an annex showing the best practices, and two of these best practices I gave to you now. This one is the first and so far only climate natural holiday accommodation in Hungary. What we can do here, I mean, concerning sustainability, we can collect rainwater from the roof and use this collected water to flush the toilet and supply the washing machine. And they used sustainable building materials, and the heating is done with biomass. The other best practice is a new family house. Again, here as the ventilation is shown or provided in a passive way. And there's a straw bale wall structure with a wooden frame support. Really natural and fitting into the landscape. Through that handbook and providing this information through the project, we wanted to show that not just the declaration of performance, which is a required document in the here in the European Union, but beside that DOP, the EPD, which is the Environmental Product Declaration, is also important. This declaration is a Type 3 declaration that can quantify environmental information or impact through the life cycle assessment of a construction material or building material. General rules are laid down in the ISO standard, and there's a third party, an independent third party verifying these values, these results, what we can get through the life cycle assessment. There are programs in the EU, what I showed here, and I wanted to just check if the same program or the same document exists in the US, and I got these programs, the SMART EPD, the UL Environment Laboratory, and the ASTM International, which is the Standardization Institute, as far as I know. And some details about the Environmental Product Declaration, providing description of the product, the manufacturing process, and then the LCA and those values, the results concerning the life cycle assessment. And in Hungary, we are now introducing a database. There are simplified environmental ratings. We will do it soon. And there will be another database collecting the detailed green declaration. So it's not just a declaration in the future. We have to do it now. And these declarations are really important in the procurement. I mentioned the term life cycle stages. Now I can show that to you These modules are described in details in this EN standard. And according to this picture, we can talk about the product stage, the construction process stage, the use stage, and the end of life stage. Not just a product, but a construction work. So, for example, a building. In the product stage, we take into account the raw material, the extraction, the transportation, and then the manufacturing. And we have to take that manufactured product into the construction site and create that building. And during the use stage, we need to repair or do some maintenance or replace some parts of the building. And this is our new concept when designing now a building. In the design phase, we have to take into account the end of life stage. What we will do with that building? We can just demolish it, but it's not the best. We can use some parts or reuse those materials. So that is what we would like to show and what we would like to demonstrate. The next project concerns the establishment or the installation or the building of our headquarters. This project is called the PIMES. So it's a really good play with the words, play it more efficient, Sam. So this is the Concerto initiative that was established in 2005 by the European Commission, and defining concepts were sustainability, replication, and cost effectiveness. And the project aimed at revolutionizing and modernizing cities' energy systems. Let me show the pictures. And the demo sites were in Norway, in Spain, and the last one was in Hungary, in Szentendre, where we have our headquarters. Let's see the map of Szentendre. Szentendre is a small town situated next to the river Danube. Here is the river, and this is just 30 kilometers away from Budapest to the north. And in this project, we had 4 demo sites or demo buildings. The first one was a kindergarten. I'm going to show you some pictures about the demonstration work. Some new parts, so the PV integration, the refurbished kindergarten, the 3D design, and now you can see in reality, you can compare the before and after picture, and not just kindergartens, but penalized residential buildings were refurbished. Again, the before and after. Again, really, really nice pictures and showing those tasks like integrating PV on the facade or just install new windows and new facade insulation. This was a office building, refurbished, and now we reached our knowledge center in Szentendre, the headquarters of AMI. And with this headquarters, and the demonstration, we would like to show the bioclimatic design methods. Let me just show some pictures about insulation, different window types using the bioclimatic design, like this box windows where we can shade. We can use these boxes as shading. Green facade on one end, and on the other corner we can find a climate facade. We use low temperature heating and cooling system. And again, the use of solar panels integrated into the building in different ways can be seen here. When it comes to energy efficiency, one of the biggest potential savings in Hungary can be found in residential buildings. In total, there are 4 million dwellings in Hungary, 3/4 of which were built before 1980. At that time, you can imagine energy efficiency was not a consideration in construction, nor was it a legal requirement. A deep energy renovation of 100,000 residential buildings per year would be needed to renew the domestic building stock. Energy renovations are ongoing, and the really fresh news, or the what we can learn nowadays, that the EPD recast, the Energy Performance of Building Directive recast, was adopted. So the voting was done on the 12th of April. And why I am mentioning this, because we were and we are again part of this concerted action. These projects support the implementation of the EPBD through exchange of information and experience among project partners. That was the 5th edition, and now we have the 6th edition with the new website. You can check it out. And our task, as I mentioned in the abstract, our task is not just doing it in our small community or talking about it, but we have to show, we have to demonstrate these activities. And this is what we are really proud of, the organizing the Solar Decathlon Europe in 2019. Actually, this competition came to Europe from the US at the turn of this millennium. Richard King, a scientist in the US, had this vision that he believed that the best way to encourage energy literacy was by empowering the change agents of tomorrow, so the students. By this, the competition was initiated, and the first Solar Decathlon was launched in 2002 in Washington, D.C., and came into Europe in 2010 in Madrid, Spain. And again, there were another one after 2 years in 2012. Then moved to Versailles, and we could organize this one in Hungary, Szentendre. The Hungarian edition was special because we had this main theme that renovation is important, renovation of the existing building stock, and we proposed really good challenges to the teams. Application of local recycled materials, or using bioclimatic planning, nature-based solution or smart solutions. We had 10 teams, more than 400 students participating here, representing 3 continents, 8 countries, and 27 universities. Contests, because decathlon means 10, so the contests are 10 groups, or 10 part of this contest can be seen on the screen: architecture, engineering and construction, energy efficiency, communication, neighborhood integration, innovation, circularity. These 7 are juried contests, and there are 3: the comfort condition, house functioning, energy balance, that was measured. So a monitoring system was installed in each prototype. You can see the building site, and in the rules there were strict instruction how the drawings shall be identified. You can see the monitoring activities here, and the 10 prototypes. And with this one, I would like to move to the other typical dwelling type, the cube house. There are around 800,000 of these square houses or cube houses with tent-like roofs, as you can see here on the elevation. You can see the floor plan, and these houses were built between 1960 and 1980. Most of the buildings are in bad shape, so they need deep renovation. And one group showed a really good solution. This is this consortium of a Hungarian and Algerian university. It's called the Hungarian Nest, and provided a cube house renovation. They applied many innovative technologies, as you can see and read here on the screen: speech-based emotion detection. The Venturi Tower, I will explain it on the next slide. And they mixed active and passive energy. And here you can see the system, how the passive ventilation is shown. So there is a basement under the house, under the building, where the air can cool down, and through 4 small doors we can let the air penetrate into the house, the internal side, and then through this tower, knowing the physics, the heat will rise up and leave the house. The other solution was a really good one, providing modules to be attached to the existing house. These modules can be a mechanical one, a bathroom module, or a sun space. And you can see the concept. If you have a family with more children, you can add these modules to the house, or when just when the children go out, going to a university or move out from the house, they can reuse easily the space. And with these concepts and these prototypes, we would like to have a national prototype expo park, let's say like this in English, because not just this type of houses can be renovated, but the other one and new solutions can be provided by manufacturers. And moving closer to the end of this presentation, the other project, what I would like to show, where we have really important task is to train other trainers to provide lectures and to train those architects, civil engineers practicing and talking about new initiatives. This is the BIM-Z projects, educate for zero energy buildings using building information modeling. So the term NZEB refers to zero energy buildings, and I guess you know building information modeling, or nowadays we call building information management. The aim was to directly target educators and private industry trainers and provide learning units, training material for them. First of all, just check out the needs and then provide these trainings and get feedback from them. You can see now the piloting for the students are represented here, 20 apprentices, 40 SME workers, and we implemented these pilot courses where we provided 12 learning units, 25 pilot courses were completed, students from 4 countries, more than 400 trainees. The last project is talking about another new term, the circular economy. We will not have enough time to talk about it. I just would like to raise this question to you. If you know about it, or if you want to learn more about it, you can check it out. Circular economy, and this Go Circular project is about stimulating demand for sustainable energy skills with circularity as a driver. That special one focuses on multifunctional green use of roofs, facades, and interior elements. This is the circular transition. So we have the energy transition, material, climate, and digital transition. And in this project, we work with a full value chain approach involving and connecting these relevant people and expertise, what we need, by applying the so-called key elements framework. The consortium develops a circular skills qualification framework for sustaining the built environment. Let's check out the professions and trades and materials for training of trainers, and we can provide task-based qualifications for. And this is the last slide. Now I'm stop sharing.
Anita, that was such a wonderful presentation. Very interesting indeed. And what a good way of completing the semester, talking about SDGs and Sustainable Development Goals. So I'm sure there are a lot of questions. And let me start off with Don has just posted a question. And he says, EMI are a member of CIB, and you're a board member of CIB. How would you say this engagement with CIB has benefited you and your research?
Yeah, I know my homework, Don. I have to I have to think about it. Yeah. By being the member of the CIB, I easily or simply say it provided a better understanding and a more open way to see the construction and the construction industry and what is happening in the world. Because otherwise, we are just focusing on our problems and getting tired with our problems. But if we see that these problems are almost the same in every country all around the world, we can just group together, work together, and I hope we will solve these problems. What I just talked about, the global warming problem or the climate change. So CIB for me, meaning I can talk about these problems, these scientific problems with other highly qualified scientists from all around the world.
Yeah, very well stated, Anita. I think you touched upon the very essence of CIB. That's a global organization spanning over 60 countries, and of course, all qualified, highly energized researchers in this space. So highly good group of intellectuals to talk about these issues indeed. And I'm sure there are a lot of questions. So if you have anybody has a question, please raise your hand as always, and or just open your mic and ask a question. But while you're thinking, let me throw my question about your presentation. And you know, I wanted to ask you that you mentioned about possibilities of improving sustainability, and your focus was primarily on new buildings. And I was thinking that there's so much of existing built environment that also needs to improve in terms of sustainability and related issues. So I was wondering what of your research can help some of the older buildings also be more sustainable and energy efficient.
Especially that handbook, what we provided. Usually every year in April, May or March or April, we have this so-called Construmadis exhibition, where not just professionals, but anybody can come and check out those new materials, new systems. And we introduced that handbook to the audience, and that handbook contains solutions for existing building, how we can renovate those existing buildings, and what activities we need to do in order to enhance sustainability. I didn't have time to talk about it, but yes, we need to use special bulbs or LED solutions in lighting, or selectively collect waste. That's one part, but going back to the building, yes, we need a special retrofitting in these cube houses. They are existing ones. We have to use new heating system. We have to use ethics, the external thermal insulation composite system in order to wrap these houses. So don't let the heat penetrate through the walls and save the energy.
Let me look at the audience again. Any questions? Please open your mic and ask.
This is the last one. I mean, your last course.
This is the last seminar.
Maybe the students are tired, like me.
No, this is a very interesting problem.
Sorry for my English and for my slow speaking. These 2 weeks were difficult for me, but yeah, I could make it.
Yeah, this was very nice. I'm glad you were able to take time. I had a follow-up question. You know, you also showed a lot of retrofit with solar panels, and one of your designs had solar panels for windows, for roof, and all possible spaces. So the cost of solar panels in the US for a residential application is still very, very high. And I was wondering, you know, what is the adaptability of solar panels in Europe? And do you see that, I mean, is the cost also high in parts of Europe, or do you see that cost coming down in the future?
I don't know much about the cost, but I can tell that recently we had in Hungary a program, a funding program for family houses to install PVs. So it's like a subsidy money for those family house owners, and the number of applicants was so high. A lot of people wanted to have PVs, and the problem was that the grid is not efficient or to capture those PVs and connect those houses into the grid. So they have to stop that program because a lot of people wanted to have PVs.
It's an excellent thing, right? I mean, it's a good problem to have when more people are wanting to switch to PV and also look at energy efficiencies. So that's really, really wonderful. Looks like, you know, if there's somebody has a pressing question, we can take 30 seconds. Yes. Toby, you are going to ask a question, or you're applauding?
Yes, actually, I have some question, just one.
Go ahead.
Thank you so much for the amazing presentation. It was really insightful. I think for me, one question I have, owing to the fact that we're going to the work industry soon, is as young professionals going into the industry, what would you advise to be the attitude of young professionals, knowing fully well we would not be in the front line of implementing some of these sustainable buildings, infrastructures, or materials and technologies, because sometimes we are basically going to just be at the back line, just following orders or doing stuff as recommended by either the client or the people we're working with. So what would be the advice for young professionals going to the industry, and how best can we imbibe a culture for sustainable practices? Thank you.
I could say what I did when I was younger. I learned a lot, listened a lot, and read a lot. So I did not just accept. Yes, we have this feeling towards the more professional workers that we need to accept because they have experience. But nowadays, you guys have a lot of options to check out publications, we have Google. You can easily search for those solutions and find the pros and the cons in order to choose one. But be patient.
Thank you so much. Toby, did you have any follow-up questions? I saw your...
No.
Okay. So, well, unfortunately, we have run out of time. I normally get to ask my last question, but I gave it today to Toby. So with that said, Dr. Terjek, thank you very much for taking time. This was indeed a very good capstone seminar to close out the semester. And I really appreciate you taking time late in the evening to present this seminar. So with that said, this is, as was pointed out, this is our last seminar for the semester. We'll take a break during the summer session, and we'll be back again in fall with many more exciting presentations, just like the one we had today. So with that said, let's give her a big round of applause and thank her for taking the time.
Thank you very much. I appreciate it.
Thank you.
Indeed.
Thank you for having me. And if I can be of your assistance in the future, I know Hungary is not in your focus, but if I can help any one of you, you can find me on LinkedIn, and I'll be more than happy to guide you if you want to know more about Hungary or Europe.
Absolutely. Thank you very much. I appreciate it. That's great.
Take care and have a good
You too. Thank you.
holidays.